Hello and welcome to the next chapter and the next lecture. Today we're going to speak about the messaging, and specifically in this lecture we're going to speak about the Apache Kafka. So Apache Kafka is a distributed streaming platform. So it provides you ability to reliably send data throughout the stream, or like through between the applications. So one application, for example, can be a producer which produces the events. For example, if we'll take the stock market, the producer will be some institution that provides a price that calculates everything, right? And for example, right, and the consumer can be any app that want to display it. So for crypto example, there is a Binance that displays the data for you. So this can be a consumer, for example, right? And there is also can be the in the middle something that will convert. So we'll do three of them in our case today. So let's firstly create a new app, and we can actually start with 1.3.0. So if you're watching the videos with me, you probably need to update in Maven because 1.3.0 won't work with the previous version of the Maven. So if you was watching my videos and there was 1.2.1, you can update it and to 1.3.0 and update your Maven. So if it's macOS, just call brew upgrade Maven and this will be enough. So we'll create an app as always, nothing special. So we have a Quarkus Maven plugin, 1.3.0 final, tech to now, Kafka, and the extension Kafka, nothing specific. So this will be actually enough for everything that we need. So I opened our Kafka project in IntelliJ IDEA, and let's firstly create a Docker Compose file that will help you in to start the local development Kafka environment. So nothing special. So let's create just a file called Docker Compose. Just copy over the text from the lesson. There is a description to this video, so just copy it to the Docker Compose YAML like this. So what happens here? So we have two images, one of which is a Kafka, even though we use a Zookeeper here, and the second one is Kafka as well, but you start the Zookeeper from the Kafka image, and then you start the Kafka itself. So they just use the same image for two apps, which is okay. And so yeah, so you have two services, which is one of which is Zookeeper, so it's a discovery server, and the port is 2181, and then the log dir, it's not interested for you. You have a Kafka here as well, the image here, then you have a command. So you start it, and the port, so it depends on Zookeeper, of course, so that the Zookeeper will firstly start, and then the Kafka will wait before it starts. And it's not a readiness, so it will start just after the Docker returns the information that the server was created. So just to know. And then you have a port 1992, and then you have some of the information about how to connect to Zookeeper and the ports. So yeah, let's call the Docker Compose app. So let's go to this Kafka folder, and let's call Docker Compose app, and you will see that it will start. It will load some containers if needed, and it will start all the environment. You can call -d if you need to. But in our case, we don't care about it. I'll create a new window so we can see what's going on with the logs here as well. So yeah, so now when we are here, let's create our first class, which will be producer. And today we're gonna actually do the prices. So let's create a price producer like this. And sorry, we need to create a package. I accidentally created it in there, so we need to do now price producer. So the producer will hence the name, produce the price. So we need to make it application scoped, of course. So you can create a producer by using the outgoing annotation. The name will be, for example, price, right? Let's do the price. And so here we'll use a flowable. So the flowable is like observable, but it's endless. So you can add data again and again. So we'll create long. So we'll use a long. I'll show you later why. So yeah, produce. You can name any name. Produce price like this. And so let's create a flowable interval, and we'll send. So the producer will send a random price every 5 seconds, right? So let's put a 5 time unit 10 unit seconds, and so here we'll map it. So we have so whatever there is it, right? And here we're gonna specify the let's create a new random here, private random equals new random. We don't care about the quality of the random, so we just need the random field here. And so we'll have a next int that is up to 100 or whatever you want, maybe 400, whatever you like here, like this, for example, 4000, right? And here that's the only what we want to do is to cast it to long. So I converted it to long because there is an app called Conductor, which can you visualize a little bit of data. So that's why we use long, but you're happy to use an integer as well if you want. You can use whatever you like. So there is a lot of different types. So as long as it converts and decodes, right? So you can encode it and decode it, you're fine. So yeah, so that's there. So we have you return a flowable, and we have a price here. So what do we want to do next is actually let's go to the application properties and let's specify the our outgoing Kafka channel. So I have here 3 properties that you need to specify in order to make it working. So we have here the MP messaging outgoing. So you specify that you have an outgoing producer in our case, right? So outgoing data. This is the name of the producer. In our case, it's price. You can see it here, outgoing price. And here you specify the connector. In our case, it's small Kafka. And the topic will be named prices. And the last thing that you need to specify, of course, is the serializer. So you have a value serializer, and then you have in our case, long serializer. You can put here integer serializer, wherever you want. So now this will feed the data to our Kafka. So we can actually visualize it if you want. We have a conductor here. So let's actually start our app while we're at it. And let's use a Kafka here, mainly Quarkus dev, like this. So this will start up our service. And yeah, you can see that we have already the producer config values, and here all the information about the producer. So now let's create a converter, which will, in our case, firstly it will consume the data from the price producer, right? So let's create a price converter in our case, like this. So again, it should be application scoped, right? And here we specify that we want to have an incoming, the same reactive messaging. So the value should be the name of the stream. In our case, it's prices, because we specify the topic prices here. So it will be posted, publish it in a prices topic here. So we want to have an outgoing as well. So let's say we want to have a converted prices, and you want to specify that you want to broadcast it as well. So now we'll convert it to double. So let's create a public double convert or something like this, and the incoming value will be long. Okay, so long price, right? So let's say we're converting it to I don't know. Let's say we're halving it, right? So we'll have we can do the price, return price multiplied by 0.05D or something like this. So we'll divide by half the price in our case, something like this, right? So nothing super interesting, but or actually let's multiply it by 1.5, right? Something like this. Okay, so we'll have this here. Let's as well provide the output, the input here, how we'll consume it. So now here I'll specify that we have incoming prices. That's the name of the topic that we specify right here, and so the connector will be the same Apache Kafka, but this time you can see that we have an incoming. So when you want to specify a new outgoing, use outgoing generator or whatever you have, so you need to specify MP messaging outgoing. If it's incoming, if you want to consume it, you specify MP messaging incoming, and then the name of the topic, and then all the other stuff. So in our case, connector, and then Apache Kafka, and deserializer, in our case again, long deserializer. So what happens here is that we send data to Kafka, and then we consume it back. We can do it in different apps. So you can have this part and then the price producer in one app. You can have the price converter in this part in other. So there is no requirements to do it in the same app. It's just helpful to visualize, to show you everything in one place, right? So you think about it as a two different apps in our case, right? So yeah, so now we have a producer here. And so here, as I said, we consume the prices, but at the same time, we publish the converted prices, but we're not publishing it to Kafka back, because this converted prices topic is not specified in our application's properties, right? In application properties. So there is no such, converted prices topic, right? So, and that's totally fine. So it will be published within this Quarkus project. So this will go to the, for example, our new class that will be called price resource, and we'll create a path here. Let's name it prices, right? So let's first inject the publisher in our case. So we have an inject, and then we have channel. So you can see we have a microprofile reactive messaging. So we'll name it converted prices, and this will be a publisher in our case, which will receive a double here, and the name will be publisher for us. That's okay. So what this thing will do is that it will receive everything with this publisher that was sent from the converted prices. And as I said before, it won't come from the Kafka, it will come from the local in-app messaging, right? And let's create the last thing that we are interested is the private public. Let's create a get, and then we'll have a path. Let's name it stream, and so we'll output. So we'll produce in our case media type. This time we'll have media type service sent events. So the idea of service sent events is something similar to socket. This will send you data all the time that data occurs. So it's just a channel in some case. So you can see that we have a text/event stream in our case, and the idea is that it will send you data once you request it, and it's supported natively in the JavaScript on the websites and the browsers. So yeah, so you need to specify one more thing called SSE element type. In our case, it will be a text. So you can specify here media type text HTML. All right, I'm from future back to this moment. So here we need to have text, a plain extent of text HTML, so it won't work. So don't forget to change this line of code to text HTML, text plain, sorry. So yeah, back to the lesson. So this is the type of the content that you will send all over and over and over again. So this can be whatever you like. You can put here JavaScript, the JSON, right? I will also look at it as well in a few seconds. So let's create a public, and the interesting thing is that you can reuse this publisher here and get prices, right? Something like this. So we don't need to specify anything here. So let's make it a little bit larger for you, like this, and like this. So the get prices, we don't need anything from it. We just want to have a get here and send it back. So here we just can return the publisher like this. So that's there, nothing special. And last thing that we want to modify is our index.html. I have here a super small script that will show you the actual data that is generated. And so you can see that it's HTML. I have cut everything that's possible, so we don't have an HTML tag, we just have a HTML itself. So we have a value is, and then we have a span element with the ID content. And so after that we have a script. So we create a new event source from the prices stream, which is exactly that we specified here. So we have a prices stream here. And so when we receive a message here, we change this content element that you can see. So the inner HTML, which is this one here. So we can put something unknown for now. So we'll replace this inner HTML, which is unknown, with the data that we received in our case, right? So we can actually start already. Nothing more is expected here. So let's start our Quarkus with the Maven Quarkus dev like this. So now you can see we have a consumer config, and at the same time we have a producer config. So we have the consumer and producer at the same time, and you can see that everything is started. All right, so I made small mistake here, and you need to specify here a text plain instead of text HTML. So in this case, this will work. The other one won't. Let's go to the terminal, and if you haven't started the Quarkus yet, let's start it one more time. You don't need to restart it if you don't. So let's go to our Google Chrome and let's refresh, and you can see that we have a random price each time. So you can see that it's now 2000. The previous one was 400. So every 5 seconds you can see that we receive some random number which is around 4000, right? And we also double it, if you can see it from the converter. So it's multiplied by 1.5. So every price here is 1.5 times multiplied. All right, so now I want to show you a conductor. What's going on inside of the we actually don't need to modify it, we just want to log in. What's going on with our Kafka network right now? So we can see that we have one broker, 2 topics, one of which is private, which is consumer offset, which is not required from us. So we have one topic in this test environment, right, which is prices, which is expected. So the bad thing about conductor is that it's not supporting integers. That's why I made it long. But you're free to use anything that you want, as long as you don't need to show it on the conductor. So we can go actually to this consumer groups, and let's go to the topics again, prices. So let's go to the prices, and you can click here, consume data. And here you can specify of course the topic, and then you can specify key. Key can be none, and value will be in our case long. So you can see that there is no integer. That's why I made you can show a bytes, but it won't be as clear what's going on as so you can use long, or you can whatever use a string if you supply a string. So let's start, and you will see here data, and so you see we have 8 16, and every value is multiplied by 1.5, so 28,000. So you can see 1500, and the real value is 100. And so you can see that we only supply to Kafka the value initial in long, and no data coming as a double. So that's exactly what we expected it to be. So let's change the output that we produce to the Kafka into the JSON. This is really important to know, because probably some of the data, if not all, will be transferred as a JSON in your case. Maybe not, maybe it depends on the situation, but basically the only thing that you'll need to change is a converter. So let's create price object, right? So let's create a price like this. So let's create a private, I don't know, long price, and then private string name or something like this, right? It's not the best name, but whatever. So let's create a getter and setter here, and we'll need to specify the price converter, the price producer, sorry, that we want to supply a price object like this. And here, so instead of what we've done before, we want to specify that we create a new price like this, and price set name equals Bitcoin, for example, right? And then price set price equals, again, random next int. We'll use a bound for 4,000. The price is currently 6,000, yeah, so let's put the 6,000, right? So this will be actually really accurate to the real Bitcoin prices, so it can be as it can be 0, as it can be 6,000. And we want to convert it back to the long as we had it before, like this. And yeah, that's it. So we want to return the price itself back. And so this part is ready. We need to change the serializer here. And so here we want to specify the IO Quarkus Kafka client's serialization JSON-B serializer like this. So this part is easy. Well, I mean, the second one will be as well. So the serialization is super easy because you serialize anything into JSON. So you have an object, you serialize it to JSON. So this serialization should be specified. So you can just, put a generic JSON-B deserializer and say that it will work. So what we'll need to create is, let's create a config. So in our case, it will be price deserializer. Yeah. So this will extend JSON-B deserializer, and the data will be price in our case, right? And we'll need to create a constructor, default one. So just create it like this, and we are ready to go. So we'll create a price deserializer. So we also need to specify an empty constructor here. So let's just create a constructor which will be empty like this, and we'll call it super, and type will be price like this, price class, right? We don't need actually this part. Let's go to application properties here, and here we'll specify tech.now conf price deserializer like this. So that's ready. So we can convert back the converter. So in the price converter, you put here a price as an object, and then you get price. So you can set price get price times 1 and 5 like this. So in our case it's long, so we'll use just a double. And the price here, we just need to return the price itself, and the price object will be like this. So because it's the inner stream, right? We don't need to do any serialization because it's just in-app. So we don't need to do any serialization or deserialization. So here we'll just use a price like this, and here we'll use the price as well. So the only difference is that you'll need to specify application JSON like this, and it's ready to go. All right, so now it's starting. Let's see what we'll specify. So you can see that no exception here. That's a good result. So we can go to conductor actually and see the topics. Let's go to the prices, consume data. In our case, it will be, this time it will be, we can try the JSON. I think it will be more of string. So let's see. And so yeah, there is a long deserializer. Oh, sorry, that's the key. We need this part. So let's see how it will behave. And so you can see the name BTC, price, and then you have a random price, right? So it's working fine. So you can see in output here, we have a name. So the JSON object that we produced basically, and it's working fine. So it depends what you want to specify. Maybe you need one field, right? Like a long, you want to specify one value, or maybe you want something complex. Maybe that's like a position that has a latitude, longitude, whatever you like, and whatever you need, sorry. And yeah, so JSON is a good option. You'll need to serialize and deserialize it. Otherwise the double, for example, or long will be more compact probably. So yeah, so that's there. So now you know how to use Kafka, which is really convenient, and I suggest you to use it where you need the messaging between the applications. It's really convenient, really helpful, and really robust. So yeah, you know how to create the producers, how to create the consumers, how to convert, so you have a producer and consumer at the same time, and how to convert the JSON, not only some values like a double or something like the primitives, and actually how to convert it, how to consume it from the browser, which is like just a side note here. But yeah, so I'll see you in the next video. Thank you for watching.